All right, so the first scenario, this is where you're gonna need a couple different colors. I have purple and I have red. If you have at least two, like if you have a pencil and a pen, that's good too, like one that's differentiating in color. You do wanna make sure you write or have a key or a legend that so you can explain the graphs properly and there's no questions for it. So I'll use label here, unit 13. Try to get that into focus a little better. There we go. Call it the Old Foamy Lab. That's actually what it was called. The Old Foamy Lab. So we are going to always need, as you learned from the previous videos, you're always going to have two graphs. You're going to have a progress reaction showing either exothermic or endothermic. And that's why I mentioned that at the end that there was warmth, there was heat being given off. So we know it's an exothermic reaction. So we'll make sure we adjust to draw that in the progress reaction graph. So to draw a graph though, I need to label the X and Y axis. So I'm going to number these by 10, 20, 30, 40, 50, 60, 70. I labeled the reaction, so your rate goes this way, and then energy increases as we go up. We know certain units of energy because we've gone through that unit already. So I'm just going to say joule. Again, these values and joule are coming out of Mrs. Sultson's head. Okay, so you can write any type of increment as long as you're consistent. You go by 5s, you go by 10s, you go by 15. Just make sure the increments are consistent and you've labeled the X and the Y axis. So your progress reaction, we know this is exothermic because we felt warmth. So I'm going to just show the progress reaction like this. Again, I know this is exothermic because it's giving off energy. This is the type of reaction or the type of graph that would show an exothermic reaction. I'm going to label R for reactants and P for products. So from my example, I can also figure out how much energy this reaction took place. Again, these are not actual values. I never gave you actual values. We didn't have to figure out any actual values. These are values to help explain what we see happening. Adjust it again. It's not adjusting very well. Okay, so activation energy. I'll just label it AE like we did before. It could be EA. Sometimes they like to say energy of activation. Sometimes it's AE. Either way is fine. And then I'm going to make a key over here. So my purple is going to represent 3% hydrogen peroxide without, of course you're running low, without a catalyst or without. Okay, so purple, I make a key. My purple is 3% hydrogen peroxide without a catalyst. So I progress a reaction, and I need to compare it to the kinetic energy curves. You always have these two graphs side by side. So in this case, because we are dealing with a difference in concentration and in a catalyst, we're going to incorporate that on this one graph. So I'm going to mark down the number of molecules. We don't really know the values of the number of molecules. I'll just make a note, like that's what a proper graph should look like. It should have little markings. And then we have the kinetic energy. And whether we say curve, graph, diagram, they all mean the same thing. So when you're asked to draw a kinetic energy curve or kinetic energy graph or kinetic energy diagram, they all mean the same thing. But here I have my progress reaction. So I see from this how much energy this reaction takes place. Well, I can calculate. I have a 70 up here and I have a 30 down here. So if I subtract the two, oops, that should just be equals. I have 40. In this case, it was joule because that's what I used in my pretend numbers. So kinetic energy, I'll go by tens, 10, 20, 30, 40, 50, 60, and I'll stop there. I'm going to make concentration. So again, I'm just going to make a concentration curve. We don't know how many molecules. We're just making a concentration curve. So this I have, I'll even label it lower concentration. Just to reiterate what our key is saying to us. This is how much energy it needs to react. It's 40. So at the 40 mark, you need to show that. So here is either your EA or AE is the same thing. Activation energy is right here. That means the molecules in this concentration that react are right here. There's not enough energy for them to react right here. So for showing it on it graphically, what we saw visually, these are the molecules that were reacted. Well, then we need to compare it to the second portion, and I'm going to use red for my second portion. So my red is going to be still 3%. So my concentration is going to be the same. So I can even make a line right next to it saying, I'm not changing the concentration. So I'm having the same concentration. However, in the second one, I had a catalyst. And I'll put Ki just so we know what catalyst I had. Although it's not relevant for the products and reactants, we do know we have a catalyst. So what happens to our activation energy when we include a catalyst? Reactants are the same. Products are the same. The only difference is there's less energy needed for the reaction to occur. So I apologize if this wasn't exactly next to each other here, but this is the only difference, this marking. So your activation energy is the only difference in the progress of reaction. Same reactants, same products, different value when you're talking about activation energy. On this graph, it's 3%. So I have not changed my concentration. I haven't increased it yet. That was the next one that we did with 30%. But in this case, I've done 3%. So that's why I just kind of wrote the 3% underneath there. So let's figure out what is the new activation energy. I'll walk it across and I have a 50 and I have a 30. So I have, the difference is 20 joules. So on this kinetic energy, I'm going to show my difference. So here in my red is my new activation energy. So we saw a little bit more bubbles happening when we added a catalyst. So now the molecules that are reacting are slightly more. So you always need to remember that when you have a progress reaction, you need to show the kinetic energy. Okay, I'm going to make a note. I guess it doesn't really matter what color, but I'm just going to put note. You want to make sure you show your energy of activation or activation energy. Again, it could have been EA or AE, the line, on your kinetic energy curve diagram, graph. Just giving you different vocab of that same thing. Okay, so you need to show the activation energy because that shows you how many molecules in this case reacted.